Okay, we're going to now take a look at the homework assignment for 2.1. Let's see here, get this thing zoomed in a little bit. Okay, find the slope of the tangent line to the parabola at the point 1, 5. So remember here that we're saying that our x is 1 and our y is 5. And then here is our actual function. We could rewrite the y here as f of x. So the slope of the tangent line is equal to the limit as x approaches whatever x value we're going to. In this case, it's 1 of f of x. Now, the function itself is 6x. Oh, sorry. Oh, man, that got zoomed in again. Okay, sorry. Let me write out definition of f of x minus f of 1 over x minus 1. So that's what we need to figure out. So this will be equal to the limit as x approaches 1 of f of x, which is 6x minus x squared, minus f of 1. So what do we get when we plug 1 in here? We get 6 times 1 minus 1 squared. That's just going to be 5. Now we could have seen that right here, that when we plug in 1 we get 5. But I'll just show you that you can evaluate it. And then this is all over x minus 1. Now that's equal to, if we were to take the limit right now, we'd still get 0 over 0. If you try and plug in, we would get the form 0 over 0 if we tried the limit. So we need to do some algebra here. What I'm going to do is take that numerator. I'm going to rearrange it, negative x squared plus 6x minus 5 over x minus 1. I notice that the numerator is a quadratic. It's a trinomial. I'm going to try and factor it. So limit x approaches 1. Might be worth it for me to factor a negative 1 out of the top. Might make it a little bit easier for me to factor. And then depending on your techniques of factoring, how comfortable you are with them, we would get limit x approaches 1. Got the negative 1 on the outside. Let's see. That factors to be x minus 3 times x minus 1 all over x minus 1. So just, you can double check. I'm sorry, I said x minus 5 times x minus 1. Double check this here. X squared, we get minus 1x minus 5x plus 5. So that does work. And notice here that the x minus 1's cancel. So all you're left with is the limit as x approaches 1 of negative 1 times x minus 5. If I now let x become 1, we get 1 minus 5, which is going to give me negative 4. But then I multiply it times negative 1, so I get 4. So the slope of the tangent line here should be 4. Now it wants the equation of the tangent line. So remember that whenever we're in part B, whenever we're trying to find the equation of a tangent line, what we do is we use this formula, y minus y1 equals m times x minus x1. Here we know what y1 is. It's x1 and y1 is just a point on our graph, the point on the graph. So that's going to be the 1, 5. So we go y minus 5 equals the slope, which we just found to be 4, times x minus x1, which is 1. And then I can say this y minus 5 equals 4x minus 4, distributing the 4. Add 5 to both sides. We get 4x plus 1. So there's the equation of our line. Now, for part C, we want to graph the parabola and the tangent line. So for graphing the parabola was y equals 6x minus x squared. One way you could do this, you could find the x-intercepts first, so you could set it equal to 0. You could factor out an x, set each of the factors to 0, and that would give you x is 0 is 1 x-intercept. The other one is x is 6. And we know that this parabola opens down because this opens up. Because we have a negative in front of the x squared. You could also find the vertex. Let's see if these graphs, which ones we can eliminate here. We can eliminate this one for sure. And then when we go to graph our line, remember our line, when we graph this, so if we graph this, has a y-intercept of 1 that comes from this, and that has a slope of 4. So up 4, 1, 2, 3, 4, and over 1. So we'd have a line that looks like this. So it could be this one. Couldn't be this one. And let's look down here. Can't be this one. That's a flat line. So it looks like this. Looks like they're counting by 2s here. 2, 4, 6, 8, 10. So this looks like the one. All right. Now let's see. We want to see the solution here. There it is. Okay. So now let's take a look at number 2. So consider the curve here. So it's the same sort of problem. We want to find the limit x approaches a, or x approaches 1, right? So this will set up exactly like the other one does. The curve that you get will be a cubic function. So you'll be able to determine what it looks like. So I don't think I'll work through this one because it's the exact same setup. So I'm going to just bypass that. Okay, find the equation of the tangent line to this curve. I guess I'll work through this one. All we want is the equation, all right? So we don't have to do graphs or anything like that. First of all, remembering I have 2 and 4 here, what I want is the slope of the tangent line will be the limit, this time as x approaches 2, of f of x, which was x cubed minus 3x plus 2, minus f of 2. Now, of course, if you plug 2 into this, we should get 4. So this should be 4, and then all over x minus 2. So what happens here is we get limit x approaches 2 of x cubed minus 3x minus 2, because you do 2 minus 4, all over x minus 2. And now we run into a little bit of a problem because the numerator has 3 terms, but it's not quadratic, it's cubic. So the question is, how can we factor it so that we can get this x minus 2 to cancel? That's kind of the key to this whole thing. We know we want this to cancel. So we're hoping it divides into this. So what I'm going to do is I'm going to use, I can use long division or synthetic division. I guess I'll use long division because it's more powerful. With long division, what we do is we take the top, x cubed minus, now we don't have an x squared, so we need to put a space here for x squared, and then minus 3x, and then minus 2. And then on the outside, we're going to divide by x minus 2. So we ask ourselves, what do we have to multiply x by to get x cubed? Again, this is long division, so if you need to go back and review long division, you can. To multiply x by something to get x cubed, I need to multiply by x squared. And then what I do is I multiply x times x squared, that's x cubed, I put it here. And I multiply x squared times negative 2. I get negative 2x squared. I line it up underneath the x squareds. Come through, change the signs. Subtracting basically changes the signs. And then go ahead and go down with this. These two cancel. Nothing, 0x squared plus 2x squared is 2x squared. Negative 3x, and then this is really like a 0, so adding nothing to it gives us negative 3x. And then over here, adding nothing to negative 2, we get negative 2. So now we ask ourselves the same thing. What do I multiply x by this time to get 2x squared? So I need to multiply by a 2x. Then I multiply 2x times x, I get 2x squared. I multiply 2x times negative 2, I get negative 4x. I come through, I change the signs. This is minus, this becomes plus. I go ahead and I go straight down with this. Negative 3x plus 4x is x. And then just bring the negative 2 down. And then what do you have to multiply x by here to get x? And so we have to multiply by 1. Distribute the 1 through, we get x here. Distribute the 1 to negative 2, we get negative 2. Come through, change the signs. Add down, we get a remainder of 0. And that's a great thing, because it means that this limit right here turns into limit x approaches 2. When I divide these using long division, all I get is this piece right here. So I get x squared plus 2x plus 1. And now I just let x go to 2. So if x is 2, this is a 4. And then here, plus 4, and then plus 1. This is 9. So the slope of my tangent line is 9. And then I'm going to use my formula y minus y1 equals m times x minus x1 to get my equation. So y minus 4 equals the slope I just got, x minus 2. Let's distribute through here, 9x minus 18. Let's add 4 to both sides. And you should get 9x minus 14. And we will check that real quick. Curious to see if the book did the same way or if they did synthetic division. They use the other definition. Okay, well this is worth looking at. They use the other definition for the slope of the tangent line. And by using the other definition, when they work this out, everything goes away. They get an h to come out right away, and then it cancels. So two different approaches to the same problem, you get the same result. So I'll leave that there for a second so you can look at it. So remember, on the definition of the tangent line, there's two different really approaches to it, two different formulas. And so depending on which one you use, it will dictate, how easy or hard it is. There's no like rule of thumb that you can use, unfortunately, that will always work, or it will tell you which way is better. You just have to kind of try one. If it doesn't look good, go to the other one. All right, find the equation of tangent line of the curve at this point. So let me do this one using the other definition. So here's what I'm using. The slope, got to keep remembering to use my smaller pen there. Slope tangent line could be limit h approaches 0, f of c plus h, or a plus h, sorry, minus f of a over h. That's one way to do it. That'll give you the slope of the tangent line at x equals a. The other approach is the one I was using before, limit x approaches a, f of x minus f of a over x minus a. So those are the two definitions I can use. I've been using this one in my examples, so I'll use this one right now. So here's our function over here, f of x equals square root of x. So let me go ahead and, good, I've got some room here. Slope of tangent line is equal to the limit h approaches 0 of f of a plus h. Now remember, a in the problem is 81. So what happens if I plug in 81? Well, I'll write it out. F of 81 plus h minus f of 81 all over h. Okay, this is equal to the limit h approaches 0. Okay, what happens when I plug in 81 plus h into the function? I get square root 81 plus h. Then minus over here, plugging 81 into the function, I have square root of 81, which is 9, all over h. Now, if we try and let h go to 0 right now, we will get 0 over 0. So I need to do some algebra. And since I see a square root, two terms, I'm going to come in with conjugate, top and bottom. And then when I go through on the top with that conjugate, multiply through and FOIL out, the first multiplication, the roots go away. I'm left with 81 plus h. The middle terms will cancel, so I just have to look at that last one, which is going to be negative 81 all over h times that conjugate that I had introduced. And on the top, the 81s cancel, and all you're left with is an h. And that's important because the h up here will cancel with the h down there. I'm left with a 1 up here. So here's where I am. Limit h approaches 0 of 1 over square root 81 plus h plus 9. Now I actually let h go to 0. When h goes to 0, this term will go away, and we'll be left with 1 over, notice I'm not writing the limit anymore, square root of 81 plus 9. But square root of 81 is 9, so 9 plus 9, and so I get 1/18. So that's the slope of my tangent line. Now I need to find the equation. So I'm using my y minus y1, here in this case is 9, equals the slope m, 1 over 18, times x minus x1, or x1, which is 81. And then I can go ahead and distribute through. So we get 1/18 x minus, let's see, 9 halves. Let's see, I get 81 divided by 18. 9 goes into 81 9 times, and 9 goes into 18 twice. So I get 9 halves. And now I need to add 9 to both sides. 1/18 x minus 9 halves, and then plus 9. I'm going to rewrite 9 as 9 over 1, and then I'm going to multiply top and bottom by 2, which will actually give me 18 over 2. I'm getting common denominators, so I can put these two together. And so I get y equals 1/18 x, and then plus 9 halves. That should be the equation of my tangent line. So we'll take a look at that. And look at, in this one, they use the other definition, figures, right? Well, we get the same result again, so you can see. I'll leave that there for a second so you can see how they did it this way. They still had to do the conjugate, so it just, the algebra works out a little bit different. Okay. Real quick, I've got to do a pause. Okay, let me get back to this here. All right, where are we here? All right, find the slope m of the tangent to the curve, and they give you a curve there, at the point x equals a. So what we want here is to find a general tangent, slope of a tangent line. So what we're going to do is we're not going to use a specific number, and we get to choose which definition we want to use at this point. Okay, so let me take a stab at the definition that I'm going to use here. We have to pick one of them. So let me use the one with h approaches 0. Let's try that one. So what I want to do is figure out what this limit is. Now, I'm just going to say equals. Limit h approaches 0. So I need to know what f of a plus h is. So what would happen if I take a plus h and plug it in for that x and that x right there? We would get 5 plus 5 times a plus h squared minus 2 times a plus h cubed, and then minus, now this is important, f of a. Now f of a is what I get when I plug a in for x, and I'm subtracting the whole thing, so I'm going to have 5 plus 5a squared minus 2a cubed all over h. Now, when I look at this, I realize that I'm going to have to square a plus h, and then I'm going to have to distribute through with a 5, and then I'm going to have to cube a plus h, and then distribute through with a negative 2. Just to show you the contrast, let's look at the other definition. Let's see if that one looks any better for us to use. The other definition would say that we need to find the limit as x approaches a of f of x minus f of a all over x minus a. In this case, we would have limit x approaches a. Now f of x is just what we have up there with x's in it, which it already has. Then subtract from that f of a, which is everything we have, replacing the x's with a's instead, and then all over x minus a. Now, the advantage to this one here is that I don't have to do any of these expansions. The bad news is that the factoring of this might be tough. So we kind of have to make a decision here in which way we want to go. Let's see. I'll go with the second one. Let's just see what happens with it since I'm already here. Let me just continue writing. Limit x approaches a. Now notice, when I do distribute through with this negative sign, right, when that negative sign goes through here, it creates a plus 5 minus 5a squared plus 2a cubed. And this 5 and this 5 will cancel. So what I'm left with is 5x squared minus 2x cubed. Then I have minus 5a squared plus 2a cubed all over x minus a. So at this point, what I'm going to do is try and group some stuff together on the top. Try and see if I can't factor somehow. So because I have 4 terms up here, let me attempt a factoring by grouping. So I'm going to split the 4 terms here, try and pull a GCF out of the first 2. But what I see is in the first 2, I can pull out an x squared. I'll be left with the 5 minus 2x. And then if I pull out the second 2, if I pull out an a squared, actually, let me pull out a negative a squared. Negative a squared, I will be left with a 5 plus 2a all over x minus a. So notice what happens here. We try and group. These 2 things don't match, and so grouping isn't really working there. So that approach doesn't work. Now, what I can do, I don't want that. Did not want to erase all that. Sorry. What I can do instead is try and rearrange things. 5x squared minus 5a squared minus 2x cubed plus 2a cubed over x minus a. So I put my square terms side by side and my cube terms side by side. Now, out of the first 2 terms, I can factor out a 5. When I do that, I'm left with x squared minus a squared. On the second 2, I can factor out a negative 2. And what I'm left with is an x cubed plus a cubed all over x minus a. All right, and then what I notice is that I have difference of squares here. And over here I have sum of cubes. So because, oh, you know what? Hold on a second. Pull down a negative. I need a negative there. Minus a cubed. Because when this -2 distributes back through, I need that to be a plus. So so I have a difference of cubes here. I have a difference of squares here. Remember, x squared minus a squared will be equal to x plus a, x minus a, and then x cubed minus a cubed is x minus a, and then x squared plus x times a plus a squared. These are formulas from college algebra. And notice each one of them has the x minus a that I have in the denominator that I'm going to need to cancel. So I take, this is limit, x approaches a of 5. Now here's my difference of squares, x plus a, x minus a, minus 2 times x minus a, x squared plus ax, or xa, plus a squared. All of this over, let's squeeze it in here, x minus a. And now the x minus a, since it's common in each one, could factor out and then cancel out there. So we're left with, I'll just write in red, limit x approaches a of 5 times x plus a, that's what's left here, minus 2 times x squared plus ax plus a squared, and then all over 1. So I don't really need to write it, but I'll put it here. And now what we do is we let x approach a. So if x becomes a, we have a plus a, that's 2a, and then multiply that times 5, so we get 10a. And then over here we have a squared plus, remember x is becoming a, so a squared plus a squared, that's 3a squared, and then multiplied by this, so we get negative 6a squared. And then all over 1. So this is it. This is the slope of my tangent line, 10a minus 6a squared. Whew, that was a lot of work. Now, we need to finish the rest of the problem, but what I'd like to do is see if they used that formula or not. Hopefully they used the limit with the h. Let's see. Yes, they did. Okay, so remember we had gotten this here. They expand this out and get this. They expand this out, get this. And then they distribute the 5 through here. They distribute the -2 through here. They clean all that up, and they get this. And then each one of these terms has an h, so they factor it out. These cancel. This is what they're left with. They go ahead and let h go to 0 now, and it's left with 10a minus 6a squared. So I'm glad they used the other approach because that shows you both ways. All right. Now, to answer the rest of the question, I'm going to erase all this. Most of it, not all of it. Just clean up my page a little bit here. So find the equations of the tangent lines at the points 1, 8, and 2, 9. So now we have the general formula, 10a minus 6a squared. That gives the slope of the tangent line at any point. So let's start with this one here. Here, x is 1 and y is 8. So the slope of the tangent line there at that point will be equal to the x, which is really our a. The formula here was 10a minus 6a squared, so it'd be 10 times 1 minus 6 times 1 squared. So this is just 4. So the slope of the tangent line is 4, and then we can use the y minus y1 thing. So y minus 8 equals 4 times x minus 1. Remember, I'm using the point 8 there, 1 there. And then y minus 8 equals 4x minus 4. Add 8 to both sides, and we get this. So that answer goes here. And then to do the other one, this one, first we have the slope of the tangent line will be equal to 10 times A, which is 2, minus 6 times A, which is 2 squared. So we get 20 minus, let's see, 2 squared is 4, times 6 is 24, so we get negative 4. And then we find the equation tangent line using the y minus y1 in this case is 9 equals the slope negative 4 times x minus x1, which is 2. Distribute negative 4 through, and then add our 9 to both sides. Negative 4x, what's that, plus 17. So those are our two lines. That answers that. So to graph it, you can check with these, you know, which are which. I can already tell you it's not this one because we didn't have a flat line. We didn't have a flat line. We definitely didn't have two flat lines, so it's going to probably be this one here. Let's go back over here and verify everything. Where am I? Oh, I'm going to have to go back to this because I downloaded it. Okay, so here were the equations that we got, and that's the graph. Long problem there. Okay, if a ball is thrown into the air with a velocity of 38 feet per second, and its height in feet are given by, after t seconds, given by this equation, find the velocity when t is 1. So what we basically want to know is what is the, if we look at this now as like a curve, all right, and we want to know what's the slope of the tangent line at 1. That's what the velocity is. It's the slope of the tangent line at t equals 1. So I want to know the limit as h goes to 0 of f of 1 plus h minus f of 1 all over h. Now I'm using 1 because they wanted 1 second here. If it was 2, I would put 2 plus h and then f of 2. So this is equal to the limit as h approaches 0. Now I'm replacing my t in my formula with 1 plus h. So I have 38 times 1 plus h minus 16 times 1 plus h squared. And then I subtract from that f of 1. So what would happen if I plug 1 in here? 38 times 1 is 38. And then t squared, so 1 squared is 1. 16 times 1 is 1. So, 16. So we get 38 minus 16, which gives us 22. All right, sorry, I got a phone ringing here. Of course, it's solicitation because I'm at home, and that's all the phone calls I ever get. And then all that over h. Okay, now I'm going to have to go ahead and distribute the 38 through here, and then I'm going to have to square this and then distribute a 16. So let me work that through here. This is equal to the limit. H goes to 0. I have 38 plus 38h. That's just distributing here and here. I'm going to wait to do this. I'm going to minus 16. Now, if I expand this out, 1 plus h squared, I get 1 plus 2h plus h squared. And then I still have minus 22 out here, all over h. And then I'll distribute that. Limit h approaches 0. I have 38 plus 38h minus 16 minus 32h. So I just did minus 16 minus 32h minus 16h squared, and then I still had minus 22 there at the end. I'm running out of space. Definitely running out of space. All over h. What you'll notice here is that 38 minus 16 is 22, but then I subtract 22. So those are gone. I have 38 h's, and I take away 32 h's. That's going to leave me with 6 h's. So here's where I am. Limit h goes to 0. I have 6 h's minus 16h squareds all over h. Since the numerator I have h's, in both terms, I can factor an h out. I'm left with 6 minus 16h all over h, and voila, I've got my cancellation. Now let h go to 0. This is going to vanish, and I'm just left with 6. So that will represent the velocity of the ball at exactly 1 second. So 6 feet per second. All right, let's see. If f of x equals 6x squared minus x cubed, find f prime of 1 and use it to find the equation tangent line in the curve. So this is pretty much the same thing we've been doing. You know, I'm not going to go through this one because we've done so many of these. And here's the answer. I'll just leave it up here for you so you can see how it's worked out. You're just finding this right here, the derivative at 1 just means slope of tangent line. So you use that formula, plug in, cancel out an h, and then you get a result. Then you create the tangent line from that. So same thing we've been doing. Same thing here. Okay, we've got a curve. Here it is, and we want to find the f prime of 2, which is the slope of tangent line at 2. And I think I will show you the solution to that, so you can at least see how that one worked out. Let me see. The algebra of this one's going to be kind of ugly. So we're going to use the h goes to 0 here on this one. And remember, a is 2 because of the point we're asked to look at. So we're going to be really finding this. When you plug 2 plus h into the function, you have to plug 2 plus h in right here and 2 plus h in right here, and that's what this is. Then you subtract f of 2, but we already know f of 2 is 2 because of the point. So that's just a 2. At this point, you have to get common denominator. So they went ahead and expanded this out and put all this together and got this. And then what they did is they introduced on the top here and on the bottom of the 2 that denominator. And that way they both have the same denominator. Then they put those together, distributed a -2 through, got everything to cancel out. Here we have an h in both terms. They factor it out. The h's cancel. They're left with this. They let h go to 0. That goes away. They have a -2 on top. Everything here goes away. They're left with a 6. And it reduces. You get -1/3. And then they come up with the equation of the tangent line using the y minus y1 equals m times x minus x1. And there it is. And then they go and they look at the graphs and compare. So that is that one. All right, this one, same sort of thing. We're going to find the, it's basically saying find the slope of the tangent line at a. So they don't give you a number. So we want to use the general definition. And so you're going to replace your x here with, right, we're trying to do f of a plus h. So you replace the x with a plus h, replace it with a plus h. Then you subtract from that f of a. So you replace everything here with a's, subtract the whole thing. That's why it's in parentheses. And then they go ahead and expand that out, distribute a 2, multiply -5 through here, 4, and then they distribute the negative sign through those 3 terms. Cancel things out. All the terms in the numerator have an h. Factor the h out, cancel h, and then you're left with this. Let h go to 0. All you're left with is 4a minus 5. Next one, same sort of thing. I'll let you do that yourself. This one, same sort of thing. I'll show you the work here. Here they use the other definition. Okay, they use this one. No, they're using, sorry, same one, h goes 0. So they have to find f of a plus h, so replace that x with a plus h, plus then replace the x with a. So we've got some radicals, which means you introduce conjugate, top and bottom, work all that out. When you do the conjugate foiling up on top, you'll get this right here. You clean it up, you'll get this, and then you'll have that h, and that h right there will cancel. You still have that conjugate thing on the bottom, though. And then at this point, you let h go to 0, and you should work out to this right here. Okay, a roast turkey is taken from an oven when its temperature has reached 185 degrees and is placed on a table. in a room where the temperature is 75 degrees. The graph shows how the temperature of the turkey decreases and eventually approaches room temperature. By measuring the slope of the tangent, estimate the rate of change of temperature after an hour. So what they want you to do is just look at this. This is the turkey, right? They take it out of the oven. Here it is, 175 degrees, or 185 degrees. As time goes on, it starts to cool down and reach room temperature. At a specific point in time, exactly 1 hour late into, 1 hour after they take it out of the oven, they want to know how quickly the temperature is changing. So they don't want to know what the temperature is. They want to know how fast it's changing, how fast it's decreasing. So you want the slope of this kind of reddish line here. So we need to just estimate that slope. Like what's rise over run? So you just kind of pick a point here, and then maybe pick a point here. Try and figure out how much did it go down by, how much did it go over by, and then estimate it. And let's see what they estimated here. Yeah, okay, so they, let's see. See, they're kind of guessing. They come out to negative 0.7 for a slope. Negative 0.7. So if this is 150, then it looks like really close to 150 here. So maybe that's 148. It's where it was there. And then when it gets to here, it looks like maybe it's, I don't know, 102. So the rise, or actually you should say you go down here. This is actually, it went down, so down by about 46 degrees. That's your rise, negative 46 degrees, over your run, which is the time. And here the time is kind of obvious. That's why I picked those 2 points. That's 60 minutes. And so I would have got, had I done this, 46 divided by 60, I would have gotten negative 0.76. So I would have had a different estimate than they had. But it's the idea here that's important, all right? Okay, so same sort of thing. I'll let you work through that one yourself, except they're talking about different points and different rates of change. So see if you can figure that one out. It's all estimations, though. Okay, this is all an estimation. So see how you can do on that. All right, hope that helps.